Ever watched a cake puff up in the oven? Or seen iron slowly turn reddish brown? What you're witnessing aren't just everyday events, they're powerful chemical reactions at work, silently transforming one substance into another. But here's a fun twist: not all reactions behave the same way. Just like stories have genres, like thrillers, comedies, and mysteries, chemical reactions also come in types, each with its own personality. Understanding these types isn't just science. So, if you've ever been curious about the invisible transformations happening all around, get ready. Let's dive into the 5 essential types of chemical reactions every budding chemist should know. Think about mixing cement and water to make a strong, solid paste, something new, something useful. That's exactly how a combination reaction works. It's when 2 or more substances come together to form a single product. Here's a classic example right from your textbook. Calcium oxide, also called quicklime, reacts with water to form calcium hydroxide or slaked lime, the very mixture used for whitewashing walls. But this reaction does more than just mix, it gets hot. It releases heat, making it an exothermic reaction. Let's take another example. C plus O2 gives CO2. This happens when coal burns, releasing heat and light, the same energy that powers your home and cities. So next time you see a glowing bulb or feel the warmth from a heater, you're experiencing the power of a combination reaction in action. In a combination reaction, we saw things coming together to make something new. But what if we go in reverse and break things down? Welcome to the world of decomposition reactions, where a single compound splits into 2 or more simpler substances. Let's look at the 3 main types, each triggered by a different form of energy. First, thermal decomposition, powered by heat. Take calcium carbonate or limestone. When heated, it breaks into calcium oxide and carbon dioxide. This reaction is widely used in the cement industry. Second, electrolytic decomposition, triggered by electricity. When an electric current passes through water, it splits water into hydrogen and oxygen gases during electrolysis. Third, photodecomposition, caused by light. One of the coolest reactions. This is used in black and white photography. Light breaks down silver chloride to produce a visible image. So here's the trick to remembering it. If a substance breaks down using heat, light, or electricity, you're looking at a decomposition reaction. Imagine this: you're watching a dance, and suddenly, a stronger dancer steps in and takes over someone else's partner. That's exactly what happens in a displacement reaction, where a more reactive element replaces a less reactive one in a compound. Here's a textbook example from your own lab. When you dip an iron nail into blue copper sulfate solution, you'll notice the blue color fades and the iron nail gets coated with reddish-brown copper. Why? Because iron is more reactive than copper, so it displaces it from the solution. Here's another classic one. Zinc plus copper sulfate gives zinc sulfate and copper. Here, zinc replaces copper, again, because it's higher in the reactivity series. These kinds of reactions are vital in the real world. They're used in battery cells, in metal extraction, and even in chemical sensors. It's all about reactivity and who's strong enough to push whom out. Now imagine 2 pairs dancing, and midway, the partners switch. That's the idea behind a double displacement reaction, where ions from 2 compounds swap places, forming 2 new products. Here's an example. BaCl2 plus Na2SO4 gives BaSO4 plus 2NaCl. So what's really happening? The barium ion from barium chloride pairs up with the sulfate ion from sodium sulfate. Together, they form barium sulfate, a white solid that doesn't dissolve in water. This kind of reaction is called a precipitation reaction because the insoluble product settles out as a precipitate. Think about it. You mix two clear liquids and suddenly, a cloudy white solid appears. That's not magic, that's chemistry in action. Let's talk about one of the most important forces driving chemistry, oxidation and reduction, also known together as redox reactions. Sounds complex? Don't worry, it's actually a simple tug of war. Here's the idea. Oxidation means gaining oxygen or losing hydrogen. Reduction means losing oxygen or gaining hydrogen. Let's take a real example. Copper combines with oxygen to form copper oxide. Since copper gains oxygen, it's oxidized. Now reverse it. Copper oxide loses oxygen, so it's reduced. Meanwhile, hydrogen gains oxygen, so it's oxidized. Two things happening at once. One substance is oxidized, the other is reduced. This is what makes it a redox reaction. And guess what? Even the air you breathe uses redox. When glucose in your body reacts with oxygen to release energy, that's oxidation in action. So, keep exploring. Because behind every fizz, flame, and color change, there's a chemical story waiting to be told. Let's bring it all together. Why does understanding chemical reactions really matter? Because once you know the types of reactions, you begin to think like a chemist. You can predict what will happen in experiments, balance chemical equations more easily, and connect chemistry to the real world, from energy and medicine to food and materials. Now time for a rapid-fire recap. Combination, when substances join to form one. Decomposition, when one breaks down into many. Displacement, when one element kicks out another. Double displacement, when ions switch places. Redox, the give and take of oxygen or hydrogen. Every time you spot one of these reactions, you're not just observing, you're decoding the language of chemistry.